Hello. I am Zara. And today we are gonna learn about gravity and forces. What is a force? A force is a push, or pull, on an object, resulting from one object's interaction with the other object. Whenever two objects interact, a force acts on each of them. For example, a force is applied to strike a ball with a bat. This is known as applied force. Types of forces. There are two types of forces, namely contact forces and non-contact forces. Contact forces are forces that act between two objects that are physically touching each other. Applied force, tension force, drag force, frictional force, and normal force are some of the examples of contact forces. Non-contact forces are forces applied to an object by another object that is not in direct contact with it. Gravitational force, magnetic force, and electric force are some of the examples of non-contact forces. What is gravity? Gravity is a non-contact, invisible force that pulls two objects having mass towards each other. This means, where there is mass, there is gravity, which also means, if there is mass, there is gravity. Hence, mass is an important condition for any object to have a gravitational force. The more the mass of an object, the stronger will be its gravitational force. But gravity can get weaker with distance. Hence, the closer the objects are to each other, the stronger their gravitational pull is. For example, Earth's mass makes gravitational pull on the mass in our body. This is the reason why we land back on ground whenever we jump. Who discovered it? About 300 years ago, somewhere around in 1680s, an English mathematician, named Sir Isaac Newton, discovered gravity. So, does this mean people were floating before 1680s? Well, no. It's just that gravity has always been existed. But it took a genius mind to discover it and introduce it to the world. If all objects exert gravitational pull towards other objects, then why do all the objects not get pulled towards each other? Gravity exists in everything that has mass, and the greater the mass, the stronger is the gravitational pull of that object. Hence, everything around us has their own gravity, be it objects like tree or human bodies. But their mass is less, and that is the reason why their gravity is extremely weak as compared to the gravitational pull of the Earth. Therefore, it is not felt by other objects around them, and this is the reason why all the objects do not get pulled towards each other due to their weak gravitational force. Why is the Earth's gravity weaker than the Sun's? By the Newton's law of universal gravitation, the more the mass of an object, the greater is its gravitational pull. The mass of Sun is about 330,000 times than that of the mass of Earth. In fact, the Sun contains 99.85% of all the mass in the solar system. This means that the Sun is extremely gigantic as compared to Earth, or any other planets in the solar system. This is why its gravity keeps all the planets close to it, in a particular orbit. If Sun became smaller in mass, then it would affect its strength of gravity, as well. Its gravity would become weaker, because of which, it would no longer be able to hold Earth and other planets in orbit. Earth would, then, float away, and get colder, and existence of life on Earth would become impossible. Hence, because of its huge mass, as compared to Earth, Sun's gravity is the strongest, making Earth's gravity comparatively weaker. Is mass the same as weight? Explain the difference in 2 columns. No, mass is not the same as weight. In fact, mass and weight are 2 different things. Mass is the amount of matter in a material, whereas weight is the measure of how much the gravitational force acts on that mass. The more the mass of an object, the stronger is its gravity. The stronger the gravitational force acting on an object, the more weight it has. Units of measurement of mass is gram, g, and kilogram, kg. Units of measurement of weight is newton, n. Mass can be measured on a beam balance instrument. Weight can be measured on a spring balance instrument. Life on Earth is possible because of gravity. Justify the statement. Imagine, if there was no gravity in Earth, then everyone would be freely floating, like us in space. And if things were to be floating randomly, then they would bump into each other, without any control. It would have also been difficult to have a meal, or even cook one. Though everything that has mass has gravity, but it takes a really gigantic thing, with a lot of mass, something like Earth, to have a huge amount of gravitational force, in order to keep things, with weaker gravity, under control. It's because of Earth's gravity, that we have an atmosphere. It's because of atmosphere, we are protected from harmful radiations of sun. It's because of atmosphere, we get some % of our daily need of oxygen to breathe. And finally, it is because of Earth's gravity, that we don't float off in space, bumping into celestial bodies. Hence, we can say that life on Earth is possible because of its gravity. Do you know why an astronaut who weighs 72 kilograms on Earth would weigh less on Moon? Mass of the Moon is 1/6 of the mass of the Earth. Hence, the gravity of Moon will also be 1/6 of the gravity of the Earth. The weight of an object is the measure of how much the gravitational force acts on that mass. Therefore, the objects on Moon will weigh only 1/6 of their weight on Earth. So if the astronaut, who weighs 72 kilograms on Earth, would weigh only 12 kilograms on the Moon. Escaping gravity. In order to escape the Earth's gravitational force, the object needs to exert a huge amount of force, acting opposite to the direction of the Earth's center of gravity. Hence, rockets and other spacecrafts are able to escape Earth's gravity and venture into space with the help of fuel combustion that generates lots of energy, allowing them to escape the Earth without falling back to the surface. How does birds, airplanes and helicopters resist gravity? Earth's gravity affects everything on Earth. But with a force called lift, birds can resist the gravity and fly in air. They lift themselves against the gravity by flapping their wings, pushing the air molecules down, which in turn helps them push up higher in air, making their flight successful without falling back to the ground. The same principle works with airplanes and helicopters. They have fuel energy that exert lift force on them, and, with the help of the huge wings, in airplanes, and fan blades, in helicopters, the air molecules are pushed down, allowing them to stay in flight, resisting the gravity. What is an object's gravitational field? We know that every object that has mass has gravity. The area around an object, within which it can attract other objects, is called the object's gravitational field. For example, the planets in the solar system fall in the gravitational field of the Sun. Therefore, they orbit around the Sun. But there are other celestial bodies, like stars, far away from the Sun, which are not attracted to the Sun, because they do not fall under the gravitational field of the Sun. What is air resistance? When an object moves through the air, it faces some resistance from the air molecules around it. This decreases the speed of the object. This resistance is called the air resistance, also known as drag. Air resistance acts against gravity on falling objects like apple falling from tree, and on objects passing through air, like flying bird. What would happen in the absence of air resistance? In the absence of air resistance, all objects would fall with the same speed towards the ground, irrespective of their masses. For example, a stone is way heavier, as compared to a piece of paper. When the two are dropped down from the same height, they would reach the ground at the same time, as no air resistance is acting on them during their free fall. In the presence of air resistance, the falling objects would face the resistance from the air molecules around them. Since the lighter object has less mass, its ability to resist the air molecules around it is less as compared to that of the heavier object during a free fall. Hence, the lighter object will take more time to fall, as compared to the heavier object. For example, a stone is way heavier, as compared to a piece of paper. When the two are dropped down, from the same height, the paper being the lighter object, will face more air resistance, and hence, the paper will take more time to reach the ground, whereas, the stone being the heavier object, will face comparatively less air resistance, and will reach quickly to the ground.